Hi, everybody. This is the video for assignment 4, the work in Power Lab. This might take a while, not so much with your data collection, because you're going to be doing data collection with this, but with some of the math is fairly simple in this one, but there are a significant amount of questions. So let's go over the assignment. Oh, no idea what that happened. Okay, let's go over the assignment here. So I gave you some background here and telling you what work is, what power is. Power is the rate in which work is done. Work is the amount of force displaced, and it's measured in Newton meters, or we measure it in joules, yada, yada, yada. I already did a lecture on all of this. It tells you about James Watt, person who I don't think he first investigated work and power, but he was the inventor of the steam engine, and he used power, was calculating horsepowers because he compared the power of a steam engine to that of a horse. That's why we call it horsepower. But we've since changed. We don't really use horsepower except in the US, maybe Britain. Everybody else uses kilowatts or kilowatt hours if we're looking at horsepower in cars or something like that. But we simply say 1 horsepower is equivalent to 746 watts. So what you're going to be doing is you're going to be taking some data. So first thing you're going to do is measure your weight using a scale in kilograms, or you can measure it in pounds and convert that to kilograms. There are 2.2 kilograms for every pound. So if you measured your weight in pounds, simply divide by 2.2, or you can just simply estimate your weight. I'm not going to hold you to any standard as far as what your weight really is, or say, I know what your weight really is, you lied, or anything like that. So you can just estimate it if you want. And then what you're going to do is you're going to find a flight of stairs, okay, and measure the height of one of those stairs. I'd suggest measuring in centimeters and then converting that centimeter into a meter. And then count the number of steps in that flight of stairs. So things to look out for, your weight should be expressed in newtons. You're going to take your mass in kilograms that you either calculated or estimated, and multiply it by the acceleration of gravity, which is negative 9.81 meters per second squared. However, for this, especially if we're calculating weight, write your weight as a positive for this lab. It won't really affect any calculations, but it'll give you some funky numbers that might make it harder to understand. So it's going to give you a negative weight. Just write it as a positive. Then you're going to measure or estimate the height of one stair of your staircase, and then count the number of steps you're climbing. Multiply the number of steps by the height of one step to get the total height in meters. Then what you're going to do is you're going to get a stopwatch, and you're going to run up the flight of stairs 3 times. But, just in case it needs to be said, be careful. Don't, be careless. Make sure you're doing this safely. If you need to hold on to a handrail, that's fine. If you feel like you're being overly exerted, don't continue. We don't want to see people get hurt in the name of physics. So you're going to time yourself for each climb 3 times, and you're just simply putting it down your data in this table here. I'd suggest just type it in. You don't need to write it in and then take a photo and send me a JPEG or anything like that. Then you're going to answer some questions. Okay, your first 2 observations. Were the 3 climbing times roughly the same, or did they vary considerably? You don't need to give me this. You can if you want. If you wanted to calculate the standard deviation of all of your climbs, that'd be interesting to look at. but just kind of say like, well, were they all pretty much the same? Were they off by a tenth of a second, hundredth of a second? Were they off by whole seconds? Just let me know. Were they the same or did they vary a bit? And did you feel as if you exerted the same effort on each climb? Tell me yes, no, and possibly why. Then you're going to do some calculations. So once again, I'd suggest using the Microsoft equation editor. Like I said before, I think it looks better than writing it out on scrap paper and email and then taking a picture of it. If you don't know how to use the equation editor, feel free to reach out. I'm more than happy to show you how to use it in Microsoft Word. But you're going to calculate the work and power for each 3 of your attempts. And here is, it's somewhere in here, the conversion for this, but work is force times distance. You already calculated your force here, and weight is a force, and your displacement, I said distance, I meant displacement. And that is the height of your staircase, okay? So you take the height of one step, multiply by the number of steps, that's the total height of the flight of stairs, and you're gonna calculate it for each 3 of your climbs. Then you're gonna take these numbers here and divide it by the times you recorded here, okay? That'll give you power. So then you're going to answer a few more questions here. So was the amount of work you did for each trial the same, and why? It's not a trick question. Just kind of tell me if they were the same and why they may or may not be the same. Look at the equation here. That should give you a hint. First, power. Was the amount of power you experienced the same for each trial? Why or why not? It's the corollary to this one. Look at the 2 equations. What is different? What is the big difference between work and power? For number 3, if you had climbed more slowly, how would work have been affected if it would be affected? And how would power have been affected if it would have been affected? And explain. Once again, look at the equations. Kind of work through these and tell me why time would matter for these. And then compare your output with the output of a horse by calculating your horsepower. The conversion is in the front of this lab here. So 1 horsepower is the equivalent of 746 watts. So look at the watts you calculated here. Were they even close to that of what a horse may be able to do? And maybe the reasons, great grandparents used horses and didn't do all the work by ourselves. And then a few other questions. Okay, how does your power output in climb the stairs compare to the power output of a 100-watt light bulb? This is just kind of a fun little experiment. It's like, how many 100-watt light bulbs could you power if you're climbing up the stairs? I'm going to probably say not many, and at least not for very long. This doesn't have the time component, but I mean, it has a time component, but really doesn't work like that. We're looking at chemical energy, and this is mechanical energy, but it kind of gives you an idea of, the whole fallacy with the matrix where they turn people into batteries. Like, yeah, the body doesn't work like that. We wouldn't make good batteries. There's a whole lot of, it's like the law of several laws of thermodynamics and physics say that would be a terrible idea. Can't believe the robots thought they were smart. How do you calculate the amount of work done, the amount of power exerted? Well, I told you, I gave it to you, but I want in words, describe these equations. What is the main difference between work and power? Look at your description of them. Look at the equations of them. What is different? And then finally, 2 people climbed to the roof of a building. An old person walked up a gentle ramp. The young person climbed up a steep spiral staircase. Which person did more work, and explain? So I'm not asking you to necessarily go into the trigonometry of this. When I say work, I'm not really talking about exertional work. or perceived work. I'm looking at mechanical work. From the lecture and from this is, what is the difference here? How does mechanical work change? Does it matter the slope of the vertical climb? Would that really matter here? So I want you to say yes or no and then explain why. As always, I hope this helped. If you still have questions or you're confused, feel free to email me or reach out to me in Slack. So I hope this helped, and goodbye.